Hello everyone, my name is Hubert and welcome to Teach Me channel. Today we will be covering the topic of power calculations in GCSE physics. Now, why does this topic deserve a whole video to itself? Well, power can be a very confusing concept. It can often be confused with the strength, it can often be confused with the work done, it can often be confused with forces, all kinds of stuff. I mean, for example, we often say, when you play your Tekken video game and you knock someone out with a punch, you would call it a powerful punch. And while you're not entirely wrong, the thinking behind that could be wrong, which is why the concept of power is often confusing. Okay? Now, without further ado, let's get started. Power is the rate of energy transfer. Simply, that's what it is. It is how fast we can transfer energy from one object to another, or how fast we can transfer energy from one type to another. Now, if you are confused about energy transfers and concept of energy transfer, check out the video in the link in description below. That will explain everything for you. Okay, so knowing that power is the rate of energy transfer, this is the equation for power. I'm going to underline it for you because it's quite important. So this is the equation for power. Now, what does it mean? It tells you that power is equal to energy transfer divided by time that it took to transfer that energy. So, for example, according to this equation, we can see how powerful a cannon could be. Because cannon can launch a ball in a very short space of time, and it can launch that cannonball very, very, very fast. So it transferred a lot of chemical energy from gunpowder onto that ball, causing it to have a lot of kinetic energy in a very short space of time, in a split second that it takes for the gunpowder to explode. Now, another equation for power that you need to know is actually incredibly similar. Another equation in which we can consider power is equal to work done divided by time. Now, we already discussed the concept of work done. Work done is the energy transferred. So this is actually very similar. I'm going to write it down for you. Again, annotate it. Okay, so again, power here could be described as work done divided by time. Work done is the energy transferred. So this is the same, it just can be expressed in two different ways. Now, I'm going to underline this for you. Okay, so now what do we have to watch out for? What could be confusing? Right, power is not work done, because work done is a total energy transferred. Work done is how much energy we transfer in total. For example, to lift a barbell from the ground all the way up above your head, it takes 800 joules to do this. So if you do that, you have done 800 joules of work done. You have done work. You transferred that energy from your sort of chemical energy produced by your body to kinetic energy to lift the barbells working against gravitational potential energy. Now, okay, so now that's how it's different. Whereas power is work done over time, the rate of work done. It is how much of that work done is done per second. So this is how we differentiate between work done and power. This is how this is different. Now, power is also not necessarily the total force. It's not necessarily the sort of strength, if you will. It's not necessarily the sort of strength, if you will, of a person or an object or a movement. It is not, because again, it doesn't tell us the total transfer You know, you could be doing something with a very low power. You could be holding your hands up all day long. You could be holding up your hands up all day long and just keep holding them in place. Eventually your hands would get tired, etc., because you have to keep contracting your muscles to keep them in that position. So why are you not transferring huge amounts of energy? You are doing it for a very long time. So actually the power here would be actually quite low. But that doesn't take away from the fact that the work done, the energy transferred over that long time could actually mount up to be quite big. So that is a difference between power and this sort of conventional concept of strength or force. And I already explained the difference between power and work done. This is so important. Power is the rate of energy transfer. This is literally the single point that needs to be remembered from this lesson. Now, let's try to understand the power further. Okay, so let's imagine a scenario. We have two racing cars. We have one something like this. Look like some kind of futuristic cars, but that will do. So we have one race car here, and we have another race car here. So something like this. There we go. Green one. Okay, so we have two race cars. Now, one of them has a high power, and one of them has low power. And then they both go. Now, the question is, which one of these will get further? If they are identical, but one of them has higher power than the other, which one of these will get further? Well, this isn't actually down to power. This could be also down to efficiency, mostly to efficiency, to the design of car, to the efficiency of their energy transfer. So here, just looking at the power, we cannot tell which one will go further. However, what we can tell is that the car with higher power will transfer more energy per second. It will transfer more energy per second, from chemical energy, from petrol, to kinetic energy, to movement. So that one would transfer more energy per second. And what does it mean in our words? What would it mean in our words? That this car is simply faster. So it would get first. It would reach the end line first. However, we cannot say, knowing this information, we cannot truly say which one of these goes further, because that's more down to efficiency rather than raw power. Okay, and the final thing we need to discuss for today are, of course, units. Now, time, in both of these equations, time is expressed as a standard unit of seconds. Work done is expressed as a standard unit of joules, energy transfer the same, of joules. Now, what unit do we use for power? Well, power is the energy transferred in a given time. So, power is expressed by a unit of watt. You probably saw it in most of your sort of electricity-based appliances and everything. Okay, so now we need to discuss what is a watt. No pun intended. What is a watt? Okay, so watt is, again, rate of transfer of energy. It's a unit to express that. So 1 watt is defined as the energy transfer required, it's a definition of 1 joule being transferred per second. So 1 watt is equal to 1 joule per second. That's essentially what a watt is. So this is it for today, guys. Thank you very much for listening. I appreciate every time you watch these videos, guys. I really appreciate that. If you want to stay on top of daily videos on math, sciences, and some university level biomedical sciences, hit that subscribe button below. If you like this video, don't be shy, give me a big ol' thumbs up button, and see you next time.